Welcome. In this lesson, we're going to find the derivative of an inverse function and review the basic differentiation rules for elementary functions. In the next series of lessons, we'll learn to differentiate an inverse trig function. So let's look at derivatives of inverse functions. From earlier courses, let's take a moment and remember what inverse functions are. Given a function f of x, the inverse function f inverse of x is numerically defined to be an equation that undoes f of x. Right? The one will undo the other. Some other features: x and y are switched. And because x and y are switched, domain and range are switched. Graphically, if we were to look at the graphical representation of the inverse and its original function, so a function and its inverse, they would be reflections over the line y equals x. Let's find some inverses algebraically. So let's start with a linear example. All right, and I'm going to use the function f of x equals 2x plus 3. Our first step is to first of all, to change that f of x to a y. So y equals 2x plus 3, and then we switch the x and y. So we have x equals 2y plus 3, and then we're going to solve for y. Right? So I would subtract the 3, so I have x minus 3 equals 2y, and then divide both sides by 2. Right? So that would give me, I'm going to flip the sides. So y equals x minus 3 divided by 2, or if you don't like it like that, you can also write y equals x halves minus 3 halves. And now we can switch that y for f inverse. So we have f inverse of x is x divided by 2 minus 3 halves. Right? So f of x equals 2x plus 3, and f of x equals f inverse of x equals x divided by 2 minus 3 halves are inverses of one another. Right, let's look at an exponential example. Right, so I'm going to use the equation, and I'm just going to put a y right away instead of a, I'll put g of x, and then we'll switch it to y. Right, so g of x equals 3e to the x plus 2 power plus 1. All right, so now we're going to switch the g of x to a y, so y equals 3e to the x plus 2 power plus 1. We're going to switch x and y, so x equals 3e to the y plus 2 power plus 1, and now we're going to solve for y. So first let's get the e expression by itself. Let's subtract 1. So we have x minus 1 equals 3e to the y plus 2 power. We can get rid of the 3 by dividing everything by 3. So let's divide by 3. And then we have x, and if you want, it can be x thirds minus 1/3, equals e to the y plus 2 power. Now we have to free that exponent from e. Right? Well, what's the inverse of e? Well, of course, that's natural log. So we're going to take a natural log of both sides. So natural log of x thirds minus 1/3 equals natural log of e to the y plus 2 power. E and natural log cancel each other out. So now we have natural log of x divided by 3 minus 1/3 equals y plus 2. And our last step is to subtract 2. I think I'm going to write it over here. And then we'll switch from y back to g inverse of x. So we have natural log of x thirds minus 1/3 minus 2, oops, excuse me, close my parentheses, minus 2 equals y. And now I'm just going to switch the sides and I'll replace that y with g inverse. So g inverse of x equals the natural log, if it's in x divided by 3 minus 1/3 minus 2. There we go. Right, and so that's the inverse. And see if I can move this over just a little. No, that's kind of attached, but maybe this one will move. And then let's box our answer here. Right, and there's just a little review of inverses. So now let's find the derivative of inverses. Now that we've reviewed some algebra, consider the two functions. Actually, I'm going to stay a little bit with inverses, and then we're going to do some calculus. Then we'll find the derivatives. Let's do a little bit more review. Almost forgot. So let's consider the two functions because f of x and g of x represented numerically below. Answer the questions that follow. So one thing that students have trouble with is remembering to switch the x and y. They get confused which value they're using. So if we want to find values for f inverse, the x values for f inverse are the y values for the function it's the inverse of. Right? So for f inverse, this is going to be the x and this is going to be the y. So if we plug in 3, we'll get negative 2. If we plug in 2, we'll get 1. All right, let's look at the next one. Complete the table of values. All right, so the y value, the x values for g inverse were the y values for g of x. And the y values for g inverse are the x values for g of x. All right, so that means that if we plug in 1, we get negative 2. If we plug in negative 2 into the inverse, we get 1. All right, x and y are switched. All right, so we want to find the value of f of g inverse of negative 2. All right, so let's find that one. All right, so f of g inverse of negative 2 is equal to, so we're going to plug in negative 2 into the, so the x value for g inverse is going to be negative 2. If we plug in negative 2, this value here, into the inverse, we get 1 coming out. So this is the same as f of 1, which is equal to, so if we plug in 1, we get 2. All right? I think that's the trickiest thing, remembering to switch the x and y's. Let's look at the next one. All right, so find the value of f inverse of f of 1. All right, so f inverse. Make sure I'm not going to say derivative until we get to the derivative part. So f inverse of f of 1, that means we're plugging in 1 into the f of x, because f of x, remember, if we're evaluating a composite function, it's inside out. Right? So composite functions evaluate inside out. Right, so f inverse of f of 1, we're going to plug in 1. If I plug in 1, I get 2. So f inverse of 2 equals, all right, so if I plug in 2, I'm going to go right back to 1, right? Because this would be the x value for f inverse, this is the y value. That's going to, and remember, a function and its inverse undo one another. So we expect to get back to the original. Let me move this out of the way and get rid of that. Let's try the next one. All right, so we have find the value of g inverse of f inverse of 2. All right, so g inverse of f inverse of 2 equals, all right, so I'm plugging 2 into the inverse. All right, so this would be the x value. This is the y value for the inverse. So that's g inverse of 1. It's the inverse. So if this would be the x value. The y value for g of x is the x value for its inverse. And if I plug that in, I'm going to get -2. And that's all there is to it. So just remember that for the inverse, the value of x was the y value for the original function. And let's take care of the last one here. This one's a little longer. All right, so f inverse of g inverse of 1. It's harder to say. All right, but we start in the inside. And this thing here, that's an inverse sign. Maybe I should make that a little clearer. All right, so we're going to plug in 1 into the, so that's the y value for g of x is going to be the x value for its inverse. So this is going to be the x value. If we plug that in, we get -2. So this is f inverse of g of -2 equals, well, of course, if we plug in 2, we're going to go right back to 1. And that makes sense because g and g inverse are inverses of one another. They just cancel each other out. That's just going to leave the 1. All right, so now all we're going to do is find f inverse of 1. All right, so wait, f inverse of 1. There's no f inverse of 1 on our thing unless I see f, I see for x. Did I look too quickly? On my notes here I have 2. But something seems not right about that, because that's the f value. Let me think about that. All right, but let's leave that one there. Let's just make sure there's no mistakes. F inverse g of g inverse of 1. So if I wrote the right thing. If I plug in 1, I'm going to get -2. If I plug in -2, I'm going to go back to 1. Now if this wasn't here, if it was f of 1, let's just do f of 1. Then it would be 2. Something seems funny. I'm just going to leave it because I have no y values where f of x is 1. Right, but we'll think about that one. You think about it too. Tell me if you see something that doesn't seem right. All right, now enough of reviewing. Let's go over how to find the derivative of an inverse. All right, so we're going to prove it. All right, so we're finding a formula for the derivative of an inverse. All right, so this is a true relationship, right, that we saw on the other slide, that a function and its inverse cancel each other out. So given below is a relationship that exists when a composite function is formed using a function and its inverse. Use the chain rule to differentiate both sides of the equation and find a formula for the derivative of f inverse. All right, so we're going to take the derivative. This is a true statement, right? If function and its inverse cancel each other out, just leaves the x. All right, so now let's take the derivative of both sides. All right, so we're going to take the derivative of f inverse of x, and we're going to take the derivative of the x. We take the derivative of the whole thing, right? Because we have two functions here. Right? We can do that when we have two functions, a function on either side. All right, so now this would be a chain rule. Right? So we have to take the derivative of the outside times the derivative of the inside. The derivative of the outside would be f prime f inverse of x. Right? So this is the derivative of the outside. And now the derivative of the inside would be And I always have a hard time figuring out which one's going to go where. I may switch them, but f prime of inverse of x is the derivative of the inside. And of course the derivative of x is 1. Now we want to find the derivative of the inverse, which means right here we have it, right? So we need to solve for f inverse of x, or excuse me, f prime inverse of x. So now all we're going to do is just divide by the f prime of f inverse of x. We're going to divide by this part here, the outside part. All right, so that's going to give us f prime of the inverse of x is equal to 1 over f prime of f inverse of x. And there we go. This is going to be our derivative. So let's write this in words as well. So the derivative of the inverse So f prime inverse of x is equal to 1 over f prime f inverse of x. So in other words, the derivative, yeah, that looks clean enough, I think. The reciprocal of the derivative of the function is the derivative of the inverse at yx. And so if you are given a point on f of x, change xy to yx. Okay? All right, so now all we have to do, and that makes it nice because I don't mind finding the derivative, the inverse, especially on an easy one, but now we don't have to. Right? So we can find the derivative of the inverse simply by finding the derivative of the original function evaluated at the inverse. Right? And that's going to make things a little easier, and it's going to help us with other derivatives as well. So now let's do this two ways. This isn't a very hard inverse to find. So we'll find the inverse. All right, suppose that f of x equals 3x plus 2 and f prime of negative 2 equals 3. What's the value of of f inverse of 4 prime? See, nobody knows where to put the prime mark. They put it outside parentheses. That works too. All right, so our derivative would be y. So we have f of x equals 3x plus 2. That'd be y equals, actually, let me label that the inverse. Right, so f of x equals 3x plus 2. That's y equals 3x plus 2. Switch x and y. So x equals 3y plus 2. Subtract 2. X minus 2 equals 3y. Divide by 3. Right, and so x minus 2, let's write it as x thirds minus 2 thirds equals y. And then we can switch that back to f of x. So our inverse here would be f inverse of x equals, and that was x thirds minus 2 thirds. All right, so this is finding so here we found the inverse, and now we're going to find the derivative. And then we're going to do it the shortcut way. right, so I'll put the prime first. F prime of the inverse of x equals, all right, so now the derivative of x over 3 would be 1/3, and the derivative of the 2/3 is 0. All right, so that's the derivative of the inverse. Now let's find it. So this will be called finding, oh, I shouldn't have written in red, huh? It's going to blend into the red up above there. Let's change to black. So finding the derivative of the inverse without finding the inverse. All right, so f of x equals 3x plus 2. F prime of x equals 3. It's going to be the reciprocal. Now there's nothing, now if I had an x here, I'd have to do some evaluating, but I have no x's. So it doesn't matter whether it's -4, 0, or 1, right? There's no x's left. So the derivative of the inverse is going to be 1/3, right? Because the slope is going to be the same whether, no matter where we are, right? Because this is just a line, right? This -4 would have mattered if this was anything but just a line. In the next video, we are going to look at just finding the derivatives of inverse functions without finding the inverse. Thanks for watching. Bye for now.